Okay, in this video we're going to take a look at how to solve an equation that happens to already have a logarithm in it. In this case we just have a logarithm on one side. Now, like you approach this the way we approach all our equations, we look for the complicated portion, which it's pretty easy to tell that this stuff is the complicated piece of this equation. And let's get everything else to the other side, just so we don't have to deal with it. So I'm going to add this 5 and just move it out of there. Okay. So let's rewrite what we have. Log base 4 of x plus 1 equals 3. Now, in order to get at this exponent, okay, in order to somehow get that isolated, I've got to undo a logarithm. I've got to go backwards from a logarithm. And this is the conceptually difficult part to follow. We have to remember, what does a logarithm mean? Well, a logarithm represents an unknown exponent. Okay, now, there's a couple of ways to approach this. Let's start with the mechanical way. If a logarithm represents an exponent, then I'm going to do the opposite of an exponent, and this is kind of tough to say. It's a big word called exponentiate. And what that means is I'm going to find this base right here, and I'm going to make it a base on both sides of the equation and turn the entire equation into exponents. Now that sounds difficult. Let me show you what it looks like. 4 equals 4. That's all I'm going to do. I find this base and I write it on both sides. Now I'm going to take all of this stuff that's in the equation and I'm going to make that exponents on both sides. So log base 4 of x plus 1 and 3. So I exponentiate it. It means I turn the entire equation into exponents. And 4 was the base. Now the nice part about this is 4 to the log base 4. I've done opposite or inverse operations right there. So I'm left with x plus 1. On this side, that happens to be something I can handle in my head. If not, I could do it on a calculator. That's 64. So my last step is pretty simple. I just subtract the 1 over and I get x equals 63. Now the other way to approach this, and it's not always easy to do, especially depending on the numbers you have to work with, but once I get to this point right here, I can treat this a different way. Okay, we could write this in exponential form. 4 to the third power equals x plus 1. Now to me that's easier, but that takes a conceptual understanding. You have to remember what a logarithm represents, and if you can do that, just rewriting it essentially helps you solve the equation. Okay, notice all I did was I took this logarithm and I wrote it in exponential form, the way my mind would understand it. And I didn't have to do this and this to both sides. It already happened for me. Pretty much this right here is the same thing. Okay, it gets me to the same spot. 64 equals x plus 1. So x has to be 63. So you kind of have your option here. Once you get the logarithm isolated, you can either write it in exponential form, which is kind of what I prefer, or you could just do a mechanical process that's called exponentiate, which means we turn the entire equation into exponents and use 4 as our base, and then it'll essentially solve itself because these things will cancel each other out. So you have your choice either way. It's something that's new. It's not really all that easy at first because you're just not accustomed to that type of thing, but it all goes back to the meaning. If you can remember what a logarithm represents, you can find a way to set this problem up to solve it.